Welcome back, students. In this video, I would like to introduce sequential circuits. So this is the outline of this presentation. Okay, I'll talk about sequential circuits, what's the difference between combinational and sequential circuits. I'll talk about the difference between synchronous and asynchronous sequential circuits. I'll talk about latches as a memory element, flip-flops, okay, as a better memory element, and finally I'll talk about the characteristic tables and equations. So let's get started. So far we have seen combinational circuits, okay, at the beginning of this semester. Since the beginning of the semester until now, all my discussion was about combinational circuits. So there are two different classes of digital circuits. We have combinational circuits and also we have sequential circuits. So what is the difference between these two? In the case of a combinational circuit, the outputs are a function of the inputs only. So for a given input, there is a fixed output. So the output is uniquely defined based on the inputs only. Okay, one thing about combinational circuit, there is no internal memory. Okay, so there is no memory inside the combinational circuit. On the other hand, a sequential circuit, the output is a function of the inputs as well as the internal memory. So there is an internal memory inside the sequential circuit, and even though the input is the same, you can actually get different outputs based on the internal memory, based on the internal state. So we call it the state, which is the value of the internal memory. So time here becomes important in the case of a sequential circuit. And the memory, the content of the memory changes over time. So now, when we look at the sequential circuit, it consists of two parts. We have the combinational logic part and we have the memory elements. So the memory elements here can be latches or flip-flops. I'll talk about these in great detail in a later video. And the memory elements store the state. We call it the present state. So the output of the memory elements is the present state of the memory. So the present state means the output. So what we are storing inside the memory elements appears at the output of the memory elements. The combinational logic is going to receive some inputs, is going to receive the present state from the memory elements, is going to compute the outputs of the sequential circuit. Notice that the outputs depend on the inputs as well as the present state. Okay, so therefore, even for the same inputs, you get different outputs if the present state is different. So the output can change based on the value of these memory elements. The next state, okay, which appears here, okay, is also computed by this combinational logic. So the combinational logic is going to produce this next state that becomes an input to the memory elements. So the value of the memory element changes, okay, according to the next state. And this can be controlled, for example, with the clock. The clock is not really shown in this slide. I'll talk about the clock in a later slide. So there are two types of sequential circuits. We have the synchronous sequential circuit and also we have the asynchronous sequential circuit. Synchronous means that we are using a clock signal as an additional input to the sequential circuit, and the clock is going to be used to synchronize, to indicate when we change the value of the memory elements. So we control the memory elements using the clock. So the changes will happen at discrete instances of time. So this is synchronized with the clock. This is why it's called synchronous. On the other hand, asynchronous, there is no clock signal, and therefore we can do changes in the memory elements can happen at any instance of time. Now our focus will be on the first type, which is synchronous sequential circuits. So all the changes will be synchronized with the clock. This will be easier to design. It also will be easier to analyze than the asynchronous sequential circuits. Here is the block diagram of a synchronous sequential circuit. Notice that the clock now is connected as an input to the memory elements. So the clock is used to control these memory elements. It indicates when we change the value of the memory elements. Okay, as I said before, that the present state is the output of the memory elements. and this is what we have. This is what we are storing inside the memory element. It appears at the output. The next state is the input to the memory elements. So this is the value that we are going to store. It's not really stored yet. We are going to store it. Okay, this is controlled by the clock. So during the next cycle, the clock cycle, we are going to store the next state inside the memory elements. Okay, so the combinational logic, which is shown here on top, is going to produce the outputs of the sequential circuit, is going also to produce the next state. So the outputs and the next state are a function of the inputs as well as the present state. Okay, so let us take a look at the clock. The clock is a very important signal in synchronous sequential circuits. So let us understand the clock. It is a periodic signal, okay? So it means that it alternates, okay, between 1 and 0. So the clock has two levels, okay? So the level of the clock can be high or 1. This is actually shown here. So when the clock is high, it means that we have a positive pulse, or it can be low or 0. It means that we have a negative pulse. Now the clock also has two edges. It has a rising edge. It means that the clock will go from 0 up to 1. That's the rising edge of the clock. Also, it has a falling edge. It means that the clock is going to drop from 1 down to 0. That's the falling edge of the clock. So there are two levels for the clock. There are also two edges for the clock. Okay, remember that the levels and the edges are very important when we talk about memory elements. Now in this slide, I'm showing that the rising edge, the rising edge and the falling edge, I'm showing the edges. The change from 0 to 1 and from 1 down to 0 is happening instantaneously in time. In reality, okay, there is a rise time, so it takes a short amount of time for the clock to go from 0 to 1, and there is also a short amount of time for the clock to drop from 1 down to 0. There are two important metrics, okay, for a clock. The first one is called the clock cycle, and the second one is called the clock frequency. So what is the definition of a clock cycle? The clock cycle is just a time duration. It is the duration between two edges, okay, two rising edges of the clock. So here we can see in this slide, we can see this rising edge, okay, of the clock, and this is the next rising edge of the clock. So the time difference or the time duration between these two rising edges, okay, between one rising edge and the next rising edge of the clock is called the clock cycle. That's by definition is the clock cycle. Now the clock cycle is just time, and we can measure the clock cycle in seconds, in milliseconds, in microseconds, nanoseconds, or even picoseconds if the clock cycle is very short. Okay, so these are important metrics, and of course you should remember what these units are. Okay, so for example, the millisecond is 1 over 1,000 of a second. Micro means 1 over a million, nano means 1 over a billion, and pico means 1 over a trillion of a second. It's 10 raised to the power negative 12. On the other hand, clock frequency means that, okay, you can count how many clock cycles per second. Okay, so in 1 second of time, count how many times the same cycle, the same clock cycle is repeated. So you can count the number of repetitions of a given clock cycle. So count the number of clock cycles per second. That's the meaning of clock frequency. And the clock frequency is measured in hertz. So this is the unit for the clock frequency. So 1 hertz means that you have 1 cycle per second. So if the clock cycle is 1 second, it means that you have 1 cycle in each second. That's the hertz. Now, if the clock cycle is 1 millisecond, then in this case, you will have 1000 cycles per second, and therefore you will have 1000 hertz, and this is called the kilohertz. 1 megahertz means 1 million cycles per second. 1 gigahertz means 1 billion cycles per second. And finally, we have 1 terahertz, which is 1 trillion cycles per second, 10 raised to the power 12. It's not really shown in this slide, but that's the meaning of 1 terahertz. Now, we can always relate the clock frequency to the clock cycle. So the clock frequency is defined to be 1 over the clock cycle. That's the definition of the clock frequency. So for example, if the clock cycle is 0.5 nanoseconds, that's the time duration, okay, of a single clock cycle. We can convert it always to seconds by multiplying by 10 to the power negative 9. In other words, we are dividing by 1 billion. So that's 0.5 times 10 to the power negative 9 seconds. Then the clock frequency will be 1 over this number, okay? It will be 1 divided by 0.5 times 10 to the power negative 9. 1 divided by 0.5 is the 2. 1 divided by 10 to the power negative 9 will give you 10 to the power 9. So therefore you get 2 billion hertz or 2 gigahertz. So if the clock cycle is 0.5 nanoseconds, the clock frequency will be 2 gigahertz and vice versa. So it's enough to know one to calculate the other, okay? So we can always derive the clock frequency from the clock cycle. Let me introduce now memory elements. Remember that sequential circuits, okay, contain memory elements. This is how they are different from combinational circuits. So a memory element can store and maintain a bit. It can store a bit, and the bit can have a value of either 0 or 1. It will store the bit until, of course, you change the value of the bit. Okay, so the bit here is called the binary state. Okay, this is the value that appears at the output of the memory element. Now, there are different types of memory elements that I'm going to describe in my next video. Okay, so we can distinguish between different memory elements according to the number of inputs they have, and also how these inputs affect the state, the binary state of the memory element. I'm going to talk about two main types. Okay, the first type are called latches. Okay, and these are sensitive to the level of the clock. I'll talk about flip-flops, and these flip-flops are sensitive to the edge of the clock. This is why it's important to distinguish between the level of the clock and the edge of the clock. Okay, so the level of the clock, it means that the clock is either high or low. The edge of the clock means either the rising edge or the falling edge of the clock. So the flip-flops are sensitive to the edge of the clock, while the latches are sensitive to the level of the clock. This is the main difference. This is actually the difference between the latches and flip-flops. Today, people use flip-flops. They are used in synchronous sequential circuits, and these flip-flops are built with latches. Okay, I'm going to talk more about this in my next video. So in my next video, I will introduce latches. Okay, then I will talk about flip-flops and characteristic tables and equations. That's it, okay, for this video. Thank you for watching.